Hello everybody! Today I'm going to test a cheap, small, lightweight 5000 mAh power battery bank which I recently bought in a shop called Action. I'm going to continue with the specifications of the item, and then I will do the unboxing, and then I'm going to check the capacity of the item, then the power output of the item, and then also I'm going to test the small USB cable which comes in a package. After that I'm going to test how much percentage it can charge up my phone. So let's get started and continue with the specifications. So this is the power bank in its original packaging. The brand name is Reload. According to the packaging, it has 2 years of guarantee. It is a 5000 mAh power bank, 5000 mAh at 3.7 volts with Type-C in and output, so you can charge it and discharge it using the Type-C cable. It can charge your phone to 50% in 40 minutes. Well, actually that depends on the cable and your phone also. It has Type-C in and output, so not the Type-C cable, but actually a Type-C port. And it has two USB ports. I will show you that later. It has a USB cable, which is here. And you can take it in the airplane, because it's a small power bank. And now let's see the specifications on the other side of packaging. You can see the specifications in many different languages. So the first is the English. So again, the brand of the item is Reload. I bought it in Action. And this is a 5000 mAh power bank. And here's the barcode. I'm going to put that in the description below. So let's see the specifications. The internal battery is 5000 mAh at 3.7 volts. The input is 5 volts, 2.1 amps. This is the maximum. And of course it depends on your charger, so your charger should support the 2.1 amp charging. There are two normal USB-A ports which supports 5 volt 2.4 amp charging. If you use both of the USB ports for charging, then the power output is split between the two ports. The max output in that case is also 2.4 amps. And also there's USB-C port, which input is 2.1 amps and the output is 2.4 amps. And again, the total output is 2.4 amps, so if you charge more than one device with that power bank, then the power output is split between the USB ports. And then in the last line you can see that it has a micro USB charging cable included in the box. On the bottom of the box you can see the USB charging cable, and of course I'm going to test that later on in this video. So as you can see, the power bank is quite small. Here is the USB cable included and also the user manual which is wrapped around the USB cable. So let's continue with the unboxing of the item. So I continue with unboxing of the item, removing the item from the packaging. I'm going to fast forward it, so in a few seconds you will see the end result. So this is the USB cable and the user manual, and then I remove the power bank from the packaging. So here is the power bank. You can see that it's quite small, and also next to that here's the user manual and the cable. Let's continue with the cable. This is an anti-theft tag, so I just threw that out. This is the user manual. It has many languages inside. I'm going to scan it and share it, and you will find a link to it in the description below. So this is the user manual. It contains many languages. And let's continue with the cable then. So this is the USB cable. One side is the USB-A connector and the other side is a micro USB. It is to be used for charging the power bank. The length is 34 centimeters. So as you can see, the size is very small. It is only 101 by 64 by 15 millimeters. The weight is only 117 grams. On the back of the item you can see the specifications of the item. There is some extra information here compared to the back of the paper packaging. I'm going to scan it also and also upload it, and you can find the link in the description below. The extra information is that the capacity is 3.7 volts, 5000 milliamp hours, which is 18.5 watt hours. And the total output is 12 watts. Now, of course, we are going to test it if the capacity is correct. And also I'm going to test if it supports 2.4 amps output. Let's continue with the ports of the item. On the front of it you can see the USB-C port on the middle and two USB-A ports. On the side you see a strap attachment, that's just a hole. So you can attach a wrist strap on the power bank. Okay, let's see the left side of the item, which has a micro USB port, so you can charge the power bank using that port. And on the right side of the item you can see the power button. If you push it once, it turns on and shows the charging level of the power bank. So this is it. I show you the sides of the item again. So now let's continue with the first test. I'm going to check how much the item is charged right after it was bought. So the item is not fully charged because I just did the unboxing. So I'm going to check how much the power bank is pre-charged. So if you need to charge your phone, this test will show you how much it could charge it right out of the box. So let's continue with this test. So let's turn on the power bank, and on the capacity meter you can see that the voltage without load is 5.12, 5.13. I turn on the capacity meter and I increase the load to 1 amp. And the voltage has been dropped to 4.99 volts. Under the voltage you can see the actual current, which is about 1 amp. And on the bottom of the screen at the cap line you can see the measured capacity in milliamp hours. On top of that you can see the capacity in watt hours. You might notice that I don't use the USB cable which came with the power bank. I used actually a better lower resistance cable. Now the power bank got empty and it turned off, and you can see the results here. So the capacity is 10.4 watt hour, which is the preferred way to compare the actual capacity with the capacity in the specifications. The capacity in milliamp hours is 2083, but keep in mind this is 5 volts. And in the specifications, the capacity is 5000 milliamp hours at 3.7 volts. So that's why it is better to compare the capacity in watt hours. So now I'm going to remove the power bank from the capacity meter. I'm going to fully charge it and then run a test to see how much is the full capacity of the power bank. So I start to charge the power bank, and you can see the LED or LEDs are blinking. If the first LED is blinking, that means the charge is between 0 and 25%. The second LED means 25 to 50, the third LED is 50 to 75, and the fourth LED is 75 and 100%. Here you can see that all the 4 LEDs are constantly on, so that means that the power bank is fully charged. A full charge took 2.5 hours, and interestingly, in the first hour the first 3 LEDs were blinking, and then after 1 hour the fourth LED started blinking, and it took about 1.5 more. So now it is fully charged, so let's continue with measuring the full capacity of the power bank. So the power bank is fully charged and connected to the discharge meter. I'm going to turn on the power bank. You can see the 4 LEDs are constantly on, and you can see the output voltage is 5.11 volts. And let's start the discharge process with 1 amp load. In the first line you can see that the current voltage is 4.88 volt. The current is 1 amp. And on the last two rows you can see the capacity in milliamp hours and watt hours. So this test will run for a while, but let's cut to the end result when the test is complete. So the test has been complete and here is the results. The power bank is completely discharged, and here you can see that the capacity is 14.4 watt hours. And the capacity in milliamp hours is 2954, but keep in mind that this is at 5 volts. So it is better to compare the capacity in watt hours than in milliamp hours. And you can see that the discharge took 2 hours and 57 minutes with 1 amp discharge current. On the bottom two lines you can see the capacity in milliamp hours and watt hours, which you saw in the previous screen. The capacity stated in the specifications is 18.5 watt hours and the measured capacity is 14.4 watt hours. And you might think that the power bank has less capacity than stated on the packaging. The difference between the two numbers are about 22%. The reason for this is that the power bank uses energy to convert the battery's 3.7 volt voltage to the 5 volt output, and during this conversion process some energy is wasted. That is the reason that the capacity of the inner lithium-ion battery and the measured capacity at the 5 volt USB output is different. This 22% capacity loss is normal, and I would say that the capacity in the specifications is correct. If the power bank is completely empty, then if you push the power button, then just one LED is blinking. This is how you can see that the power bank is empty. I charged the power bank completely, and now we are going to test the power output. Now the power bank is not turned on. In that case the output voltage is 2.2 volts. So let's turn on the power bank. Press the power button and the voltage goes up to 5.11 volts, and let's start the discharge process. On the top of the screen you can see the amp value that I set. I increase it to 1 amp, which I use to test the capacity of the power bank, but let's go further and let's increase the amps. As you can see, at 1.5 amps the voltage is 4.92, and let's increase it further. At 1.7, 4.9 volts, 1.8, 4.88. So you can see some small voltage drop. At 2.1 amps the fan turns on to cool down the discharge meter, and you can see that the voltage is 4.86, 4.87. Usually that's the power input of a phone, which can be charged with the micro USB. So you can see that the power bank can support 2.2 amps. Now let's increase the amps further. Now I'm at 2.2 and the voltage dropped to 4.84, 2.3 at 4.84 about, and that's the official maximum power output of the power bank. And let's increase the amperage further. You can see that at 2.6 amps the voltage dropped to 4.63 volts. And let's go further to 2.7. So now we are at 2.7. At 2.8 that was 3 volts, and 2.9 the power bank just shuts off. So we can say that the stated maximum output of 2.4 amps is correct. So in this next test I'm going to check how much it can charge up my phone. First I completely charged the external battery, and I discharged my phone down to 5%, and I turn off my phone, and then I'm going to check how much it can charge up my phone. I am going to use a high quality USB USB-C cable. One end is a USB-A connector, which I'm going to connect it to the power bank, and the other end is a USB-C connector, which my phone has. And I turn on the power bank, and then it starts to charge my phone. I turned off my phone just to prevent any application or the screen using the battery, so that way we can measure the exact charge that the power bank can provide. So you can see the charging has started. Currently my phone is at 5%. This is a Sony Xperia 1 Mark III phone, and this phone has a 4,500 mAh battery. So we will see that how much the power bank can charge a phone with a battery like this. So the power bank got empty. I'm going to remove the USB cable from it, and let's check if it's really empty. One LED is blinking, so that means that it's completely empty. Let's remove the USB cable from my phone and turn on the phone to check how much is the battery at. As you can see, the phone is at 84%, so that means that the 5000 mAh battery bank charged up 79% of phone with the 4500 mAh battery. Keep in mind that energy is wasted during the discharge of the power bank and the charging of the phone, so that is why there is difference, which is normal. So let's continue with the cable test. I'm going to compare the cable which came with the power bank to a high quality cable. So this is the cable which came with the power bank, and this is a high quality cable from the Orico brand, which I use to discharge and charge the power bank. I know that this cable has low resistance, so it can support more than 2 amps. This is the charger which I'm going to use. It is measured and it can support 2.7 amps, so it's more than enough to test the cables. We are going to test the voltage drop of the cables. I'm going to set this discharge meter to 2 amps, and I'm going to measure the voltage that comes out of the cable. The higher quality cables has low resistance, so basically the voltage which comes out of the cable will be higher, and we are going to measure that. So first let's start with the cable which was made by Orico, and this is a short, about 25 centimeter cable, which I use on my devices because I know that it is a high quality. So let's connect it, and the output voltage is 5.21, and let's turn on the discharge meter and set the discharge current to 2 amps. As we can see that the voltage is dropped to 5.02 to 5.03. So you can see that the current is 2 amps. 5.03 is the output voltage, and we are going to compare this with the other cable which came with the power bank. Now let's turn off the discharge meter and remove the cable and replace it with the cable which came with the power bank. So this is the cable of the power bank, and let's take a look of the resistance of the cable. I'm going to connect it and start the discharge process. So we can see that at 2 amps the output voltage is 4.77, 4.79, let's say 4.8 volts, which is much lower than the other cable's output voltage, which was a little bit more than 5 volts. So we can say that the Orico cable is much better quality, has a lower resistance. So I would highly recommend to replace the cable which came with the power bank with a better, higher quality cable. In this example, I use the Orico branded cable, which I bought from Aliexpress, and I'm going to put a link in the description below if you would like to buy the same cable what I have. If you don't want to buy the same cable as I have, then I would recommend to buy one which is short, less than 25 centimeter long, and branded, and supports at least 2 amps of power. So let's continue with the summary, where I talk about the specifications and the test results. The manufacturer is Reload, and you can see the barcode in the second line. The power bank has 2 ports where you can charge it. It has a USB-C port, which can be used for discharging or charging the device, and has a micro USB port, which can be used for charging only. It has 3 output ports, 2 normal USB-A type and 1 USB-C type. The size of the power bank is 101 by 64 by 15 millimeters. The weight is 117 grams. The official capacity of the battery inside is 18.5 watt-hours, which is 5000 mAh at 3.7 volts. The measured capacity is 14.4 watt-hours, which is less than the official capacity, and the reason for that is the energy loss during the conversion to 5-volt output. The difference between the official capacity and the measured capacity is about 22%, so that amount of energy is lost during the discharging process. The battery bank can charge a phone with a 4500 mAh battery to about 80%. Keep in mind that I charged my phone while it was turned off. If the phone is turned on, then the application is running in the background and the wireless connections are using some energy, so in that case this external power bank would charge the phone less. Generally speaking, this 5000 mAh power bank can charge a phone fully, which has a 3600 mAh battery. There is energy loss during the conversion process to 5 volts in the power bank and during the charging process in the phone, so that is where this difference comes from. The capacity when you buy the power bank is 10.4 watt-hours, so it is charged to about 72% out of the box. The measured max output power is 2.4 amps, which is the same as written in the description of the power bank. Charging the power bank from 0 to 100% takes about 2.5 hours. I tested the micro USB cable which comes with the power bank and compared that to high quality cable. I didn't use the power bank as power source, instead I used the good quality USB charger. I tested the cables with 2 amps load, and the result was that the output voltage of the high quality cable was 502 volts, while the cable of the power bank was 4.77 volts. That means that the resistance of the supply cable is higher, which causing more voltage drop. So I would recommend to replace the USB cable which comes with the power bank with a high quality one. I included some links in the description below if you would like to buy one. And finally, I have a recommendation if you would like to store the power bank long term without using it often. My recommendation is to keep the power bank at 80% charge for long-term storage. Lithium-ion batteries lose energy storage capacity if they are stored at 100%, but it is safe to store them long-term at 80%. In my case, I use the power bank in case of emergency. I keep it in my bag with me, and if my phone is dead and I can't charge it with a wall charger, then I would use the power bank. That means that I have to store the power bank long term without using it much. So first I charge the power bank fully, then I charge up my phone plus 16%. That way I discharge the power bank to 80% charge and then store it at that level. I hope that tip helped you keep your power bank in good condition. So that was the end of the specifications and of this video. If you have any questions or remarks, then share it in the comment section below. Thank you very much for watching my video. If you found that useful, informative and added value to you, then please like this video and subscribe to my channel. So thank you again and see you next time in my other video.